For this video, we are going to determine these echelon forms here as to either it's a row echelon form, or is it a reduced row echelon form, or both, or neither. You need to understand the correct forms or correct echelon forms because these are very important as we go forward in solving linear systems which will use these concepts. Now, there is a unique difference or comparison between row echelon forms and reduced row echelon forms. Actually, there's only one criteria that will actually differentiate them. But I'm saying this already. When we talk about reduced row echelon forms, it's actually row echelon form as well. So there's no reduced row echelon form only. So the options here would be row echelon form, both reduced row echelon form and row echelon form, or neither. Let's have the first example here. We have a 3x3 matrix with these entries here. We have one row, the last row, being the rows for 0. This is an example of both. Here are the criteria. First, we have leading ones. Okay? Just like that. And the leading ones, or the leading one of the next row, should be placed right after, or the next column. I mean, leading one here is one column after this leading one, and that meets the criteria. We also have 0 rows at the bottom part. That makes it row echelon form. What makes this reduced row echelon form is the entry above the second leading 0, which is 0. If all entries on the same column containing the leading one are all 0, then it means it's a reduced row echelon form. So the answer for number 1 is, or the first 3x3 matrix given here, is both. Let's jump to this next 3x3 matrix on the other side. Okay, we have leading 1. Okay, that's a leading 1. However, we have an entry here which is 2 right after at the bottom of the leading 1 here. This is neither reduced row echelon or row echelon because we have here an entry which is non-zero right after or below the leading 1. It should be, looking at the first example earlier, all entries below leading 1 are zeros, just like this. Okay, but since we have here 2, that makes this neither row echelon nor reduced row echelon form. Okay, going back to this now here, this 3x3 matrix here, we have the first column which are all in 0. Okay, however, it won't, if we're going to look at it as a linear system, this means that we have no other variables on this specific column here. So it won't matter with regards to the identification, since this is also both row echelon and reduced row echelon form, because this criteria here, having leading 1, okay, has zeros at the bottom of it, as well as this leading 1 also 0 right here. So this is an example again of both row echelon and reduced row echelon form. Now let's consider this next 3x3 matrix here. Now we have leading 1 and all the entries below it are 0. We also have a leading 1 here, okay? And we might notice that some entries, or one entry above it, is a non-zero. So this could not be reduced row echelon form. Let's look into now the consideration as to whether this is row echelon form. There's one thing that makes this neither. That's your second row. Your second row are all 0. So for this to be considered as a row echelon form, there should be an interchanging of second and third row. And if ever your second row of zeros will be your third row, and this now will be your second row. This would be a row echelon form, but for this given, it's neither. Here, for this 2 by 4 matrix here, 2 means there are 2 rows and 4 columns, so 2 by 4. We have leading 1. Below it, we have 0. The next row, we also have a leading 1. Okay? And the entry above it is also 0. This is an example of still both row echelon and reduced row echelon form. Even if we have entries here which are non-zero, since they do not belong to or in the same column of a leading 1, so it won't matter as to the identification of it being row echelon or reduced row echelon, because we're just going to look at the leading 1 and whether the leading 1 has no other or 0 entries below it and above it. So this is an example of both row echelon and reduced row echelon form. Here in this next 2 by 4 matrix, still 2 again, 2 rows, 4 columns, we have leading 1s. Okay, leading 1 for the first row, leading 1 for the second row. However, this leading 1 is located right below the first leading 1. This, if this is placed here and this would be 0, then this is considered as a row echelon form. But since both leading 1s are on the same column, this is also neither. Okay, neither. Okay, now let's move to this 4 by 5 matrix. We have 4 rows and 5 what do you call it, 5 columns. We have leading 1 here. We also have leading 1 here. So same concern as this earlier. This is also neither. Okay, so it's neither. Now let's have for our last matrix here, which is a 4 by 5 matrix. We have a leading 1 and all the entries below it are all 0. This is also a leading 1 and all entries below it are also 0. This is also a leading 1 and the entry below it is also 0. So this is actually this fits the criteria for the last row also contains all 0 entries. However, this is not just row echelon form, but this is also both. Why? Look at the leading 1, this leading 1 here, the entry above it is 0. This leading 1 here, the entry above it are also 0. So this is also both reduced row echelon form and row echelon. Now what is, we don't, all of our answers here are both and just neither. So can we have an example which is just a row echelon form? Now let me consider this this one here, 2 by 4 matrix. If this is 1, 0, and then we have another entry here, let's say 1, 1, 3, 2, 1, and 4. This is the only difference, okay? It was 0 earlier, now it's 1. This has leading 1s here. Check. The entry below the leading 1 is 0. Check. This is the example of a row echelon form, since the item on the same column where leading 1 is located has a non-zero entry of 1. So this makes it row echelon form. But earlier the example was 0, that's why they are both. So this is how we identify the echelon forms and whether it's a neither row echelon or reduced row echelon form. Thank you for watching.